Okay, in this video, we are going to continue from two examples that we did in the previous video. All right. So in the previous video, I showed you guys two examples. The first one is relatively easy. They gave us a point, and they also gave us the direction vector, and all we have to do is to find the vector equation of that line, right? So I'm going to copy that. Let me copy that. Okay, I'm going to paste it. Paste it here, paste it on this page, and let's move them up here. Oh, I'm missing something there. That's -1, 3, -1. Okay. So I have -1 over there. So that's my equation of this is the vector equation of my first line, okay? Now the vector equation of my other line is here, right? That example was a bit harder, right? It was a harder example where they gave us 2 points, that these 2 points are on the line, but they did not give us the direction vector. However, we were able to use these 2 points to come up with the direction vector, either AB or vector BA, either one is fine. I show you guys how to find the vector equation by using AB as my direction vector. Right? So I use that as my direction vector, and I got my vector equation. And I'm going to paste that on this page as well. Okay, perfect. Now, the question says this, and this is probably why vectors are so useful, right? So they want us to find the acute angle. Find the acute angle between these two lines, the two lines. So this is crazy, right? This line is in 3D, so if you think about it, so say this is my x-axis, my y-axis, my z-axis, and I have, let's say, let me use black, so a line sort of 3D that comes out like that, and then another line, let's say this is my line, like we call this line 1 and line 2. Line 2. Let's say this is my line 1, and I have another vector, another line, which goes somewhere like that, and this is my line 2, and they want us to find this angle there, and this is in 3D, right? So if we were to do this using sine, cosine, tangent, and all that, break it down into 2D, it will take us forever, right? So this is why vectors are so neat, because we don't really have to worry about any of that. Now, let's think about this. This part, this is the direction vector of your first line. And this is your direction vector of your second line. Right? Direction vector for the second line, right? So if I want to find the angle between them, so maybe the direction vector for line 1 looks like that. Maybe this is it. I said I'm going to call this B1, right? The direction vector for this vector, I'm going to call that B2. Maybe it looks like that. If I want to find the angle between them, all I have to do is to find, all I have to do is to put these direction vectors together and find this angle, right? Find this angle. That's it, right? Because my line would my first line would be like something like that, extension of this, and my line 2 will be extension of that. So all I have to do is to use these two direction vectors to help me out. So I'm going to use my dot product, right? I'm going to use my dot product. So I'm going to say my dot product of B1, my B1 dot my B2 is equal to magnitude of B1 multiply magnitude of B2 multiplied by cosine theta. And I want you guys to try this out. I want you guys to try this, and your angle should be 87.1 degrees. Since they only want the acute angle, we just have to give them the acute angle, which is 87.1 degrees. And that is the angle between the two lines. Okay? I hope you guys found this video helpful. Bring questions to class, and I'll see you guys. Bye.